I'm a movie star.
Action!
So Shlenk Line is a tool that organic chemists use to do air sensitive chemistry. And it basically is a series of glass tubes that allow chemists to manipulate the atmosphere that a reaction is experiencing. So on one end of the Shlenk Line we have a high vacuum pump, and on the other end we have an inert gas. In this case our inert gas is nitrogen. It's attached here, and our vacuum pump is down here. So say you come to the lab one day, you want to do organic chemistry, the Shlenk Line might look like this, so you have to start up the Shlenk Line. The first step always is to clean the trap, which is this piece of the Shlenk Line. So you can disconnect it here, and then rinse out the trap with acetone, water, acetone, dry it in the oven, and it should be ready to go. So then the next step is you're like ready to do some chemistry. I come to the hood, I'll turn on the inert gas flow, which is with this knob, and you can check to make sure that the inert gas is flowing by looking here and seeing bubbles, oil bubbling. So then the next step is to start introducing vacuum to the system. So I'll unscrew the trap of the Shlenk Line, set it into the condenser, the doer, and then tighten it. And then I'll attach this line. Like that. So now everything's set up to start using the Shlenk Line. First step is to turn on the vacuum pump. You can hear it kind of gurgling. And what it's doing now is it's pulling the whole system, which is filled with atmosphere, which is normal air, down to vacuum pressures. So right now the vacuum is traveling through this line into the trap up until here. The stopcock is closed. I'll turn it 90 degrees, and you should hear vacuum get introduced to the whole line. Hear that like little hiss? That means that now this whole system is under vacuum. Good practice for Shlenk Line work is to let the vacuum pump down for 10 minutes before you introduce anything to the system. So you have the inert gas going 10 minutes, you should have the vacuum pump going 10 minutes. So let's pretend that 10 minutes have passed. The next step is to cool down the trap. So basically you're running reactions where you're generating vapors of organic solvents, for example, and those solvents are caustic to the pump. So we don't want them to just fly through the vacuum and into the pump oil and then gunk it up. So this doer is designed to hold liquid nitrogen around this trap. So 10 minutes have passed, the vacuum is pumped down. I'll fill this trap with liquid nitrogen, and that cools down the trap to -200. That enables it to condense any organic vapors that escape from your reactions and prevent them from going all the way to the pump. So now let's pretend again that I've filled this with liquid nitrogen, I've given it 5 minutes to cool down all the way. Now we're finally ready to actually do chemistry. So say I want to do a reaction in this flask. I want to do some kind of inert reaction. It's like very volatile reagent or something, like it's water sensitive, it needs to be away from air. So I'll put on some kind of vacuum adapter here, and let me get this line. And I want to attach it to the Shlenk Line. So I'll take this piece of tubing and I'll turn the Shlenk Line with black facing up. That means that this flask is now under vacuum. I can't pull this apart anymore. So now this flask is at less than 0.1 millibar, assuming that the Shlenk Line has all been set up and equilibrated. Typically, you might like burn the flask with one of those heat guns or like a Bunsen burner to get out any water. And we leave it to pump down all the way for a few minutes, like maybe 3 minutes, to let the flask completely evacuate. Now I want to introduce nitrogen into the flask. So the whole point of these two-way valves is that with one direction they're under strong vacuum, the other direction they're under inert gas. So I'll turn the valve slowly, keeping an eye on the bubbler. And now the flask is under nitrogen. And good technique is to cycle a flask twice or 3 times, so twice more, to ensure that it's completely evacuated and ready to do air sensitive chemistry. So I'll repeat that twice more, and then I can do my reaction in the flask. And it's not good practice to leave the house nitrogen bubbling constantly over your reaction. So we usually use balloons. I'm going to take this guy off. So say I have my reaction in here. I've cycled it onto the Shlenk line. It's filled with nitrogen. Now I'm going to take this balloon. We should have more of these pieces of tubing. And I'll fill the balloon a few times with nitrogen. I have my balloon of inert gas. I'll put a needle on it, and then I'll put that needle into the septum. And now my reaction's under hydrogen, ready to do whatever. Okay, then you just let your reaction go, whatever. Now, say it's the end of the day, you're ready to power down the Shlenk line. The key risk of the Shlenk line, the greatest liability, is that because there's liquid nitrogen in this trap and it's under very, very, very low pressures, you run the risk of being able to condense oxygen. So that is form gaseous oxygen into liquid oxygen. Liquid oxygen is known to be explosive, so it's very dangerous to have any liquid oxygen in this system. So to avoid this, you never want the vacuum to be running with one of these lines open to the air. That will be actively pulling oxygen from the atmosphere into the trap that should be cooled with liquid nitrogen and potentially condensing it. So we need to keep that in mind when we disconnect everything from the Shlenk line. So we'll turn off the vacuum here, and then we'll quickly vent the system. So I'll turn off the vacuum, and then I'll open the system to atmosphere. And now I don't want to leave anything that's stuck in this trap to just evaporate. So I'll unscrew the trap. I'll remove the dewar, and then I'll let this thaw to room temperature. And then when it's completely thawed, you can clean out the trap and then leave it powered down like this, and that's how to take down the Shlenk line.
By the way, if you ever do condense liquid oxygen, that is pretty much the same procedure you would use. You just take the condenser away from the liquid nitrogen and let it warm up.
And you close the sash.
Yeah.
And you tell everybody, and then you walk away.
Yeah.
And you can tell you've condensed liquid oxygen because it has a pale blue color. It doesn't look like any other solvents that look white when they're frozen.
Yeah.
It like kind of has blue liquid.